So our next task, if we're given the trigonometric identities, our fundamental identities right over here in the bottom right-hand corner, what we want to be able to do is take one of these expressions, any of these expressions really, and rewrite them to simplify them. And our goal here, when we say simplify, includes the following. If we have a sum or difference of terms that include our trigonometric functions, we should be able to rewrite them so that we only have one single function or as close to that as possible. So let's see what we can do. Let's talk about this first one right up here. We're told sine of beta times tangent of beta plus cosine of beta is the expression that we're asked to simplify using our fundamental identities. Well, one trick that we can often use is to rewrite everything in terms of just sine and cosine and see where it leads. So let's do that right here. We've already got sine of beta, but tangent of beta can be rewritten as by our quotient identity as the sine of beta over the cosine of beta. And we're adding the cosine of beta here. That's over 1 though, right? There is no denominator right here. But if we put this together, we might notice something curious. The numerator is going to become the square of the sine of beta. And that's sort of a useful thing because we know that sine and cosine share a common identity, cosine of beta here. Trust me, it's a cosine down there. Plus cosine of beta. Well, if this were cosine squared beta, we could actually get that. Is there a way to rewrite this? Well, yeah, sure, right? Let's rewrite this by multiplying the numerator and denominator by cosine of beta so that we can combine these two fractions together. So I'm going to get cosine squared beta over cosine of beta again. Now we have a denominator that shares cosine of beta as a denominator. And that's a really useful thing, right? Because now when we combine them, what's going to happen? Well, clearly, sine squared beta plus cosine squared beta is divided by the common denominator of cosine beta. And let's see, sine squared beta plus cosine squared beta, yep, sure enough, that's equal to 1 over cosine of beta. And so we really have simplified this, and we could simplify it one more time because we recognize the reciprocal identity of 1 over cosine beta to be secant of beta, which is a lot simpler to deal with than this entire quantity. All right, what about other things? Well, in some expressions, we might not be able to rewrite directly. We could rewrite this using identities, but before we do that, one trick that you can use in order to help you simplify expressions is to use algebra tricks. And right here, there is an algebra trick that we can use. If you don't recognize it, it is the factoring by grouping. Remember that? Look at the first pair of terms. Both of these terms contain cosecant squared x. And so let's factor out cosecant squared x. What's left? Well, cosecant squared x times cosecant of x will equal cosecant cubed x. And cosecant squared x times 1 will equal cosecant squared x. So we're good right here. Can we squeeze another cosecant x minus 1 out of these last two terms? Well, certainly. So factor out negative 1. Negative 1 times cosecant of x is minus cosecant of x. And of course, negative 1 times negative 1 would be plus 1, which is our back term right over here, right? Now we see there's a common grouped factor right here. That is cosecant of x minus 1. And I have cosecant squared x minus 1 times cosecant of x minus 1. Anything else we can do? Well, check out those Pythagorean identities underneath, right? Cosecant squared x is equal to 1 plus cotangent squared x. So that would have to mean that we could subtract 1 from both sides right here and say that, well, cotangent squared x would be the same thing as cosecant squared u minus 1, right? So right here, this is cotangent squared x. And we're multiplying that by cosecant of x minus 1. And while that doesn't seem necessarily what we consider simplified, we say simplified in the sense that really there's only one multiplication going on. There's only one function, well, there's two functions that we can multiply here. But I think this is about as simplified as this is going to get, right? We've lowered it down from 4 terms to 1 term, 2 factors. One of those factors contains 2 terms. So it's a little bit easier. All right, how about this last one? Well, if I've got 1 minus sine of x plus 1 over 1 plus sine of x, something should suggest itself right away, and that is getting a least common denominator. Well, the LCD right here is going to be the product of 1 minus sine of x times 1 plus sine of x, and that suggests a difference of 2 squares. So let's get that common denominator of 1 minus sine of x. Multiply that by the denominator 1 plus sine of x. What would have to happen? Well, in the first fraction, we would have to multiply by 1 plus sine of x to get this common denominator. So that first numerator becomes 1 plus sine of x. In the second fraction, we would have to multiply by 1 minus sine of x. Right, 1 minus sine of x times 1 over 1 minus sine of x times 1 plus sine of x. That gives us that common denominator. And now when we combine these terms, we're going to get 1 plus 1, which is 2, plus sine of x minus sine of x, which is 0, divided by, let's see, 1 squared minus sine squared x. And that is a very familiar identity if you recognize that in our Pythagorean identity. Again, if we subtract sine squared x from both sides, we actually have the square of cosine of x. And by our reciprocal identity, this is really the same thing as 2 times the square of the secant of x. So we've actually done pretty good in simplifying these things just by using our basic identities. All right, good luck in your assignment.